Again, I hit the button. Quick fix.
Quick fix.
Hello. Very good morning. Good morning from Germany. Hi, Jemsen.
Good morning, not to you, but good afternoon to me from Singapore.
yeah, to Singapore, and good afternoon to all other people in the region. Jemsen, how are you doing?
Oh,
First.
we have a hot, humid season at this time.
Okay. Yeah. Great. The double check is
Yeah.
working. We are live. That's nice to see and nice to know. Yeah. So hot, humid is your temperature? Is your
Well,
your
we
temper?
yeah. This is the always the problem on the like us lying along the equator.
Okay. Yeah.
Yeah. You can see that my skin is always darker than yours.
Yeah. Yeah.
We have
That's
more
true.
UV.
But yeah, maybe the reason for me is that I'm spending too much time in the office.
You should come to our beach.
Yeah. Yeah, that would be nice. That would be nice. No, but yeah, good to see you again, Jemsen, and yeah, good afternoon, everyone. Wow, I was very happy to see so many people signed up. I mean, we know that some of the people cannot make it, but still, we also see in our reportings how many views afterwards we get for this webinar. And yeah, I'm happy to see. So, and Jemsen, I must admit, it's your topic.
Yes, yes, yes.
And
It is my topic, which I, in fact, is very eager to share some of the things that I had learned the hard way, so that the audience can, uh, enjoy, can pick up the easy way out from me.
right, right. And let me do something different, like we usually do that, Jimson. Let's little bit maybe turn around the order of the today's webinar. Because I think this time it's very important. The topic today is quick fix. Yeah? So we want to talk about if you're running a sample handling system, if you're running an analyzer system, and there is some problems you're causing. We will give a very short introduction why this is so relevant, the sample handling system, for the result at the end. But this time, I think it's even more important to receive the comments from the people, to receive the questions. So,
Yeah.
really, you guys out there, it's. I mean, we cannot promise that we can answer all of your questions right away. But what we can and what we will promise is that there will be no answer, no question unanswered, even if it might take us some time to get back with the answer. But I think it's important to see your comments and to get your questions. So first of all, hello everyone. It would be nice if you can just say hello from wherever you are. And I also see just recently our dear colleague Jose from the Middle East just joined in and says hello and good morning from Dubai. So it's the morning there. But again, share your questions. Give us your detailed questions. I think as you already know from the last webinars, we'll be touching on the sampling, the gas sampling probes, the transportation, the heated sample lines, and the conditioning system, the cooler. And if there is any questions or even current problems you are facing in your installation, in your system, share this with us. I think the community here really, let's say, has profits from all questions. There are no wrong questions. I must say. So it would be very nice if you share your current topics on the sample handling system, so that we can also we are, let's say, Jemsen, you. I'll be standing on the the sideline and just watching.
No, you.
But I think all of the people can pretty much, leverage from the experience you have there, and I think we can prove that there's a lot of knowledge and a lot of experience. Okay, so let's get started. As you said before, we have to make sure that we have some PowerPoints, we have some things we would like to show in detail, like you noticed from our sessions here. Let's not lose too much of time. Yeah, I said in the last webinar already that we had the first real show again here in Frankfurt, and I'm really looking forward to the AGEMA in August, 22nd to 26th of August. I really have the feeling that people are looking forward to come together again in real, not just as a digital exchange format. So we are really looking forward to this event, and our preparation have already started. And so just keep in mind, if you need any support, any invitation or anything else, just let us know, and our team is super happy to assist you, even with the hotel bookings and all of this. So short advertisement, Jemsen, for this, right? And I'm also very excited, I have to announce this, and maybe we do a webinar from Singapore next time, Jemsen, that I will come to see you again, to visit you and our partners in the region again, since more than 2 years no traveling to Asia. So I'm super excited.
Yeah, and you can come back into the studio here.
Yeah, yeah, that's true. I hope I will remember how that works with the flying and all this stuff. Hopefully, I haven't forgotten about that. Before I booked the flight, I already had to check if my passport is still valid, because I haven't used it for so long. So super excited to come back to you. Okay, Jemsen. So maybe the topics, maybe you can give us a very short introduction to the different points, to the different things which might or which can happen in the sample handling system.
Yeah, we call this time around, we call it a quick fix. Is to the whole webinar is designed, or the PowerPoint has been designed without telling long story, straight to the point. All right, whereby selection of filter, what's really happened in the process is high temperature, or so high temperature, so high dust, so high humidity, or such a corrosive sample, or aggressive like this thing. We had to have a way whereby especially the maintenance people, right? They are poor maintenance people out at the site, right, under the extreme weather. We want to give them an idea. These ideas are really come from my many years of experience out in the field, learning the hard way out. Collectively, I put them into this quick fix webinar, whereby I hope everybody will benefit from the sharing session for today.
Yeah, I think that's great. So today would be, there are some mistakes. We had a webinar before, which we called CEM, or probe sampling system configuration and layout and design. So what we are trying to answer today in this webinar is, let's assume you already picked your items and something then happens, right? So this is the guidance, this is the support we would like to give you, and maybe in some reasons also to help you out, right? So this is what we would like to talk about. Okay, James, maybe you give me 5 minutes, hopefully not more, for the very short general introduction, why this topic is so relevant. Yesterday, I can announce that we have plannings for new guests in our Meet the Expert sessions. So there will come new partners to join us here. And again, we had a very fruitful discussion about why it is so important that the analyzer manufacturer, and the analyzer system is good combined with the sample handling system. And I think quick fix, the relevancy of quick fix, Jemson, it not only shows the number of people who signed up, but it also shows these figures here. 80% of all issues, and that number really comes from I would say, one of the leading companies in this as an analyzer manufacturer, worldwide leading company. This is numbers from them. So they say 80% of all issues, problems occur are related to the sample handling system. And by the way, even more important is that a super big number of these issues arise at the beginning in the commission. So typical problems we are going to discuss here: condensation, liquid carryover, response times, and all these things is something they see at the beginning, at the installation, the commissioning of the system. So and the PowerPoint slide I've taken here is one slide from a presentation we had at the CEM conference, a virtual event this time, and it shows the importance that the effect from the sample handling system to the gas probe, or to the probe we would like to analyze, has to be reduced to the absolute minimum. And all the effects we are going to see here is the complete opposite, right? So condensation will cause damages on the probe, or will finally change the probe. And the conclusion of this presentation I've given at that time was really that any changes from the sample handling system have to be avoided. So these three typical components, I mean, we like to share this PNID overview here in our sessions. And you might remember we had the accessory session where we've been talking about also filter and other very important, maybe smaller, but very important items inside the sample handling system. So today in the quick fix session, we would like to focus again on the gas sampling probe, on the heated sample line, the transportation, and the gas conditioning, especially the gas cooling. Because we will see in the future, more requirements that sample handling systems have to be more accurate. The accuracy for the sample handling system will increase in the future, the accuracy demand, the availability. I mean, Jemson, we've been discussing this in other sessions as well. And that there is, if it's a CEM system, a continuous emission monitoring system, there are certain predefinitions of the time, the uptimes of the system. And so the availability will become very important as well. Reliability, I think, is something which is important, that there is no drift in the system after the commission is completed and the go live has happened. Have to ensure that the accuracy remains. And also, I think the data-driven world will increase, and the demand for data also from the sample handling system will increase. Okay, so I talked a lot, Jemson. Maybe for the gas sampling probes, something you can shortly pick up, or
Yeah, in fact, the sampling probe is the only component that exposed to the sample, right? So, as you know, these are extractive systems. So it is so important to get it right at the very first time, particularly when we talk about probe. The first thing that comes into our mind is we know that the probe is going to filter the particles. The first thing that comes in is how can we clean the filter. Yeah, and we're going to address this in the next few slides. Yeah, which is very important. And then what's going to have, if what happened to the sample process temperature is higher than our heated sample probe. What happened if it is higher? All right. What will happen? What is the consequences if you are, negligent? This is going to address. And then, the whole main purpose is really the sample probe is to siphon the gas in such a way, because it's the pump at the downstream, is to separate the water and the dust. All right, is to separate the water and the dust so that the sticky dust will not able to stick onto the filter element. This again, we're going to address, and all these things, what we call it the quick fix is I'm going to give you the answers, straight answers without, going beating around the bush. Yeah.
I mean, a topic like something you touched on, Jemison, for example, the clocking of the filter. I mean, there it's possible even to change the filter itself, to change the filter element, maybe to a different material if this causes some problems. I mean, the strategies we see here in order to increase the uptime of the system, this would be something really like the back purging, which helps to operate even when there's higher dust concentrations, maintenance free. And this is let's say another strategy. But today we would like to focus to talk about what happens if you run into these problems that the filter really clogs a lot. This is your list, James, and maybe you walk us shortly through without reading through it.
Well, I think the quick fix we should have long this PowerPoint presentation. I think it is that we prepared jointly. I believe the audience is going to enjoy it. Very sure. Basically, we're going to address about the most common mistakes when we talk about the probe. And there's one thing that you need to do to overcome the, literally, most of the things. Similarly to the heated line, most common mistakes that, once you buy the best heated line, if you make these mistakes, it doesn't make sense of buying a premium heated line. Similarly to the gas cooler. Why the gas cooler? We call it the heart of the sampling system, right? This will be all addressed in the following slides. Yeah, please be patient with me. Let's go on. Now, the first thing which I wanted to explain to the audience here is that many of the people from the process industry, the system integrator from the process, all right, and then they got a project from the CEM systems, and they decided to design the system in accordance to the process mindset. All right, so they applied the process sampling mindset on the emission sampling system. This is something many areas that I would say is so many mistakes are there. The reason is that the sample handling system for process are their products, they are clean. All right. As for the emission, there's only one thing you do. You just have to overcome one thing we call condensation. All right, which most of the time the process, they do not really address the condensation as emphasized as much as important as emission. All right, so condensation, if you eliminate condensation, I would say you're going to develop or design or you constructed a very robust system. All right, and the nutshell means in the whole sampling system, just focus on condensation. Avoid any condensation in the whole sampling system for emission, for CEM system. This is what I wanted to say. Yeah.
So do you also think, I mean, in process measurement, in process control measurements, Jemison, I think it's also very often the case that these are relatively hot processes, which are measured, right? So, depending on the CEM emission, the emission monitoring we are talking here, the temperatures of the chimney or the sampling or the tapping point are not that high. So maybe that could also be a reason that there is that the chance for condensation could be higher than compared to the process measurement. Is this something you would agree on? Or
this is absolutely, it's always that you see the sample that we are siphoning or extracting out from the emissions application, we are calling it flue gas, combustion gases. All right, and combustion gases coming from the raw material, depending on what type of raw material. If you talk about, many times people talk about natural gas, for example, a very clean application. However, what is the most critical part about considering the sampling system for natural gas? That is water. Many people do not realize that the natural gas has consists of lots of water in the sample. Yeah, this is something right throughout many experience. So as far as a CEM system is concerned, you realize that there's always a sample pump at the downstream. Why? Because the process is most of the time, 99% of the time, there are negative pressure. This is why you need a sample pump to siphon, to pull the sample out. All right. And different from process, normally they are positive, but emission, they are negative pressure. Yeah, this is why you need a pump. And what happened is that, when the pump siphoned the sample, and when they delivered the sample to the gas analyzer, after the pump, they push. All right, that pushing is become positive. Yeah. So the equilibrium of commissioning and at the point of commissioning, what happened if the pump, let's say you have a 5 liter per hour, or sorry, 5 liter per minute, so you're sucking 5 liter per minute. And the analyzers, most of the analyzers, infrared analyzers, not all, but most of them they require a flow rate of 1 liter. But you have a 5 liter of sample pump. Where is the 4 liter? So people think that, okay, I can have a parallel needle valve, or I can have a bypass flow meter to regulate. Yes, nothing wrong. Question, are they regulating correctly? As long as you are not doing a good job and you keep called back pressure within the pump and the gas analyzer, that portion, and the back pressure is big enough, they change the dew point. Once the dew point has been changed, you will see that your flow meter becomes sticky. All right.
Yeah.
And you will see that your repeatability of your infrared analyzer now becomes poor.
Yeah.
All right. Yeah. This is some of the phenomena that you can see.
Yeah, and the complexity, I think that also outlines this. That's the reason why I put up the PNID here again, in order to show where's the cooler, where's the positioning of the gas sampling pump, and how all of this is combined together. So, like you said, Jameson, somehow we have to speed up a little bit for the gas sampling probe. We have two situations, I think. The one situation is, and this is something you already touched on in the introduction, we might have a probe or a process temperature which is higher, way higher than the heating of the gas sampling probe. That could be the first thing. And maybe you can say some words about this.
Yeah, I think this is again very, very common, and many people are not aware that when they read our data sheet, we have mentioned that the sample temperature at the point of the answer, we say that it's 200 degrees. Some people have missed out reading that correctly. Imagine that your process temperature is 500 degrees, all right, and the heater probe is 180 degrees. What happens if you have 500 degrees goes rushing into the 180 degrees of my sample probe? What will happen is so much higher than my probe. You see, what will happen? The first you're going to encounter is your heated sample line. The tubing that connected to the sample probe melts immediately. In a short while, it melts because it is higher than the Teflon temperature of 200 degrees. So this is the first phenomenon. Number two, what happened to the O-rings that we are designed for containing a heating temperature of 180? You have 500 degree coming out. So to overcome this, the rule of thumb is, please make sure that the flange, the sample probe flange, whether it belongs to ours or belongs to the third party, the flange temperature should not exceed 200 degrees C. All right. The purpose of our sample probe is to ensure that the sample keep at the constant holding temperature of the sample of 180 degrees. So
Yeah.
irregardless of the process temperature is 500 or it is a 50 degree, our purpose is to maintain the sample temperature inside the sample probe at 180 degrees above water and above the
Yeah.
acid dew point. Yeah.
Yeah,
So
and I think that also shows this pretty good, James, in this overview slide, right? And this is the complexity, the two worlds we live in. I always say it's funny, you know, when we have interviews here with people who are even engineers coming new to this industry, and I always say, hey, why do we have a heated sample line? Why do we have a heated probe? And why do we have a cooler then? You know, and this is I like this discussion, and I like the creative answers and the
yeah,
creative
yeah.
ideas. Yeah, but that really shows kind of our. It's not a dilemma actually. It's a nice challenge or a challenge we accepted.
Mm-hmm,
But it shows we have the hot part. I mean,
mm-hmm. Yeah,
depending on what
yeah,
technology,
yeah.
analyzer technology we talk here, FTIR, for example,
Mm-hmm,
for measuring multi-components, there would be a hot extractive system. So
mm-hmm,
there would be no blue part, no cool part. But same, and therefore your topic, condensation, very
mm-hmm,
important. Yeah, the cooling might be something different. Okay, regarding the strategies of back purging, we already talked, and maybe this is also something I would consider as a quick fix,
mm-hmm,
James,
mm-hmm. Yeah, yeah,
because we
yeah,
had
yeah.
situations of installations. People shared with us, and they said, "Hey, for example, in the coal power plant, when you have the washer, the SO2 washer." You might see, depending on the technology which is used to desox, to remove the SO components from the probe or from
Mm-hmm,
out of the chimney. I think sometimes you have situations that the sample can be relatively wet, and
mm-hmm, mm-hmm,
if you use a standard tube which is
mm-hmm,
not heated, you
mm-hmm,
might see the situation that that you are already under the acid dew point.
mm-hmm, mm-hmm,
Sometimes, James, and I think our audience is maybe listening to this often enough, or
mm-hmm,
knows this just from the background. It's a different. Why do we? It's always a very common question. Why do we need that 150 or even 180 degrees?
mm-hmm, mm-hmm, mm-hmm,
Um,
mm-hmm.
this is
Yeah, yeah.
because
Mm-hmm. Because in many some some stacks, all right, especially if there is a FGD, flue gas desulfurization, whereby they use caustic or some kind of limestone or water or even seawater to wash the sample, all right. And this time there is also dust, all right. There's also particulates, and now the sample become below water dew point. The temperature is very low, and also they are sticky because they are dust. Now, then many times everybody knows that we have to find the right sample tube material to
mm,
overcome this situation. Now, the situation is that there are two options. One option is use a PTFE sample tube. The other one is a more expensive one, which is the heated tube. All right, this is
mm,
180 degrees. Now, question: which is better? Which is better? Now, through my experience after doing commissioning, right, many of the systems of FGD or even an incinerator, right, there are some incinerator which is some chemical incinerator, which the process temperature is on the stacks itself is lower than acid dew point. I want to share my experience. There's no right or wrong answer. Throughout all these many years, the PTFE tube seems to have an effect of resistance against corrosion. Yes, however, because of the sticky dust, all right, the whole tube will eventually clog up, and there's
mm,
no way you can gonna have a back purge, to clear the sticky dust without removing the entire probe.
Mm-hmm.
So my answers to the audience is, all right, get yourself prepared with a little bit premium, pay a little bit more, and get the 180 degrees heated sample tube. The purpose of
Mm-hmm.
the heated sample tube is to separate water and particles. During the journey, all right, traveling in the heated sample tube, the water and the sticky dust, it only sticks because they are together. We want to separate them, all right, so that it works, so that the maintenance itself, it gives so much more maintenance interval period in between. So this is my answer to it. The answer is that choose a heated sample pipe instead of a PTFE sample tube.
Yeah, and I think also this is something, Jemson, we can recommend. I mean, this could be also something if you experience condensate already in the primary probe sampling or in the gas sampling probe. I think it's important to evaluate where really is the condensation coming from, because this is something which is very clear. You can heat the probe body, the probe itself, as much as you want, but if there's already condensation coming from the probe tube, from the process, you will not be able to handle this in a proper way, right?
Yeah,
So
yeah.
maybe also quick fix idea, if something occurs there, there is it is possible. I mean, it's two different parts. The heated probe tube is needs a temperature controller, will be operated to whatever temperature is needed, up to 200 degrees C if this possible. And this could also be an idea if someone sees bigger problems there in the primary probe cell. Maybe I think that's already something you started to mention here, Jemson, the different components and the asset dew point. Obviously, the components in or for the gas sampling probes are important. That this is stainless steel, and depending on what kind of measurement you have to choose the right filter material, right? And this is also something in our system with our probes. You don't even need any tools. You can do it without tools. You would be able to change the filter element itself, so that should be fine.
Yeah.
As a dew point, something we already touched on, and the topic here, Jemson, is the dust particles, right?
Yeah, so this is something whereby I think this is one point up about selling ourselves to all the audience here. So we have probably for high dust, I think we are the one that proud to say that we have a very good solution. Now imagine that you have 40 gram. Imagine we have more than 40 gram, 200 gram, right, in the steel plant, in a coal-fired cement plant, right? So this is a challenge on talking about pre-filter calciner. So as far as dust is concerned, to prolong the maintenance interval, all right, to prolong, not to be absolutely have no maintenance, to prolong the maintenance interval, the secret lies is really, really on two areas. Number one is the filter element, right? The secret lies on the filter element. All right. So the filter element that we use for a high dust, all right, is actually a surface coated. It's a multi-layer. All right. So from 0.2 micron. People ask, if 0.2 micron, it can easily clot. No, this is not true. In fact, the smaller the porosity, the bigger the surface area. All right, this is one point. Number two is that we have the biggest filter element available in the SAMS market. All right, this is for true. And therefore, this also add up to the secret that we're talking about filter element. Number two, which I like to say that for very high dust, if we talk about back purge, the back purge, right? Now that we have this surface coated filter that allows back purge, we have an enhanced back purge. We call it a dual back purge, two back purge. That means the first back purge is to back purge the filter element, which is the ceramic filter, all right, with a different layer. And the outer layer is 0.3 micron. Yeah, this is a good slide of it. And then the second back purge is to deliver the first back purge that collected or inside the chamber, all right, and deliver it back to the process. All right. So this is the area. Many back purge only one time. All right. They dust out from the filter element, but over time, this particle is collected inside the chamber or inside the pipe. So we have to bring all these particles back into the process. This is why we have a second back purge. The sequence comes into it.
Now let's pretend, Jameson, someone made the big mistake and did not buy the probe from us. I mean, we are kidding a little bit here around. It's really the case that you could buy a PSG Plus probe, for example, and without back purging, and later on we could add this option to the probe. But let's now pretend, Jameson, someone didn't do it. So I mean, maybe some strategies, if you say, okay, my probe has the problem that it got clogged quite some time, pre-filter could be an option. I think this is also something we see. I mean, in our technology, in our architecture, in our probe design, we don't need pre-filter because mainly we have this big filter surface inside the probe body, but pre-filter is something we could do. And this is also one option here, which is the pressure reduction valve, the technology we wanted to introduce here, because when you have a back purging, and you might see the situation that the probe itself is getting clogged, and you have to back purge quite a lot. This back purging can also bring pressure to your analyzer system. And we always have to consider that on the probe, we have a connection to the heated sample line, avoid cold spots. Maybe Jameson also part of our quick fix, something we will discuss on the heated sample lines. But you have to make sure that the pressure is reduced before it goes to the heated sample line. The heated sample line usually heated up to 180 degrees C. The components used inside with PTFE, they get like chewing gum, so they cannot hold a bigger pressure. And therefore, it's a smart technology. And this is also something, the pressure reduction valve is also a good option, a quick fix option. Whenever you see this problem, whenever you have this problem, you could remove the normal fitting you might be using against the pressure reduction valve. We have this in two different sizes. So maybe also something to reconsider. Problems with the pressure on your system, pressure reduction valve, easy installation, and also you don't need to worry too much about any cold spot, because it is the same size, the same dimension, like the fitting who was already in there. And so it will not give you any headache in terms of heating issues. Okay, Jameson, maybe some shorter words about the aggressive gases.
See we are
already
time is running very fast. We're still at the probe. We haven't touched on the heated line, and my god. Okay, let's quick one. So it's supposed to have aggressive application like a waste incinerator, right? The HCl, HF. Yeah, please do come to us and say, let us know that the application for incinerator, so that we can do some chemical coating inside the wall of the heated probe. This is something that is additional because of our vast experience. We are able to offer not just a standard probe, but a coated probe to prolong the corrosion. All right, this is something which I like to highlight. Yeah, let's move on because we have so much to show.
You're right.
Yeah, go.
Yeah, then really, as we spend quite some time on the gas sampling probes, the heated sample lines, where we gave this overview here. our main topic, sometimes underestimated. I think that's what we said so many times here in this webinar. But really, the heated sample lines, and this is what we can give you as a quick fix advice. It's very often the interfaces between the different components with the heated sample line which can cause problems, especially in the field of condensation. And therefore, it's very important to say, if you look at the heated sample line manufactured by us, and you have to make sure, this is just an example, even if you buy this from other suppliers, please make sure that the heating goes very much up to the end of the heated sample line. Because if the heating cable might already end somewhere at the end of the cap, maybe somewhere here. I think this is also something people sometimes underestimate, how fast gas is cooling down. The heat transformation capacity of gas is so low, so the temperature drop will be immediately, and especially when we have high acid dew points, the combination of high acid dew points. And this is also something, Jemson, you don't need to worry too much in Singapore, but especially in Europe and other regions, hey, when you have cold outside conditions, minus 10, minus 20 degrees C, for example, that even makes this problem quite bigger. And if you face issues there, for example, in the connection between the heated sample line and the gas sampling probe, there's also some insulation material available from us, but also available in other sources. And this can already help you really to reach, to get a better coverage, and to make sure that the temperature remains pretty high over the acid dew point.
Yeah.
Jemson, what's wrong here?
This photo was taken by me at the site, whereby this is what I saw. Some of the, you see, many times the procurement, all right, or the analyzers, engineers, all right, they manage to explain to the end user how good the line they are purchasing, well, this is the brand, but when they hand it over to another contractor who do the installation, yeah, and that is where the problem lies, where they are not trained, they are not informed. And you can see that in this photo, you can see that the heated line, they are actually overlaying on each other. Yeah, this is a very dangerous possibility of overheating. Yeah.
So you are heading into another direction. I mean, first we talked about the situation of let's say condensation, and now we are talking about in the other direction of overheating. I mean, this is something we have to say.
The reason, because of this photo, but we're going to coming back to the condensation, and the next two slides, you will see what happened if the heating temperature is inadequate.
Yeah, maybe just 2 words. That's also pretty hard to change if the heated sample line is already installed. But if there is some insecurity also regarding particles and the efficiency of particle filtration in the gas sampling probe, many of our customers like to use replaceable tubes inside the heated sample line. So this could be also an option. We always say up to a length of 30 meters, even installed, it is possible to change. Then you just decide to choose to change the PTFE inside. Sometimes that can be pretty good. I mean, when we talk about quick fix here in the CEM system, I think the layout and the dimension of the tubes, the PTFE tubes inside, this also has a effect on the response times, obviously. But this is also something, if you once decided to go for 8 millimeter outside, 1 millimeter thickness with a 6 millimeter inside tube, it's pretty hard to change this after it is installed, right? And other effects we already touched on, you will probably not see when you choose a high quality PTFE, such as memory effects or any other effects which might come from the line.
Yeah.
Okay. Yeah.
Right. Yeah. This is another slides, that we shall see. You see the way they install the heated line, and all this photo was taken, all right, in proprietary by me. I took all this photo, and then I can see that one of them will get they burn. In fact, they caught burn, they caught fire.
Yeah.
So yeah, this is just some of the example. If only if we have a chance to talk about the heated line webinar separately, we will go in depth into the heated line. A quick fix. We just wanted to tell you these are the common mistakes.
Yeah, that's true. And the quick fix is really also to explain what can you do. And therefore, I like your idea, Jensen, to give some general hints for the installation, what you have to take care of, right? So let's pretend you have not chosen the PSG model, which you can cut to length. So you decided to go for, we also have these fixed resistant heated sample lines, which you cannot cut to length. But still, if you have to, and you have a longer length, make sure that there's enough space between the heated lines so that they are not getting too close together. Because as you can see in the picture, and this is a real threat, and this is a real problem which can occur there. You accumulate the heat, and then the materials can really start even to burn. So inside the components of a heated sample lines, and sometimes that's maybe also a little bit underestimated. The heated sample line represents the longest surface of all components in the sample handling system. So if you choose some bad material, or if this material, for example, shows some outgassing or some other effects, this will also affect your probe. Therefore, I think it's quite important to choose high quality products and to make sure that your heater is heated everywhere. Sometimes when you have zone heater and you cut this at the wrong place, you will see some problems there because there might be a cold spot even in the line.
Absolutely, yeah.
So Jensen, maybe quick fix is difficult there, but what we recommend whenever a customer or we are contacted with problems in the heated sample line, we would recommend to use an infrared camera and really try to measure the temperature of the heated sample line, because depending on what technology you use, as a fixed resistant heater, you have the situation, it's either working or not. So if this is not working, you will see immediately. But you might have a zone heater cut to length, and if a zone is not working, you will not see that in the power consumption. So in this case, you would need to have a infrared camera in order to check if the temperature is still there. Yeah, this is the spot we just mentioned. It's a crucial spot, the connection from the gas sampling probe to the heated sample line. And like we said, make sure that could be a common mistake, Jensen, that there is too much space in between, right?
Correct, yeah.
And that there's no insulation. So if there is no insulation, make it closer, cut the PTFE a little bit shorter, make sure the fitting is good connected, and then try to insulate as much as you can. Always, or sometimes this can be a potential crucial point for creating condensation.
Yeah, yeah.
Okay, I think, James, and this is the slide we should talk about a little bit, because that also, when I think about, now you have an installation and it's probably not working, or you are close to do the installation, what do you consider with the installation of the analyzer lines?
Yeah, I think there are a couple of consideration, but the first thing first, please ask a handbook, the installation handbook from the supplier. All right,
Right.
and make sure that the contractor who doing installation read the installation guidebook. This is very important. It's very important. Yeah, that when they run onto the cable tray, they don't laying side by side. You know, there is a spacing, or even if they covered the cable tray, making sure that the top has to have holes so that the ventilation is enough to dissipate the heat, and they do not double insulate the heated line, and they do not have any water collecting point like this. So all these things has been spelled out very clearly, and also what another important part that many people make the mistakes, is the banding radius. The banding radius. Oh my God, that is the banding radius that causing the cold spot without customers realizing it. By the time they're realizing it, that particular cold spot it clogged.
Yeah, that's a nice point you're touching on, James, because the material is quite flexible and it wouldn't give you too much, if you have a normal line, a power line in this thickness, I mean, there's so much copper inside and you cannot bend this too much. It's you don't have enough power to do it. But the components we use here, you're right, it's easy to overbend.
Yeah.
So yeah, that's a good
Yeah.
point.
Yeah.
And also the distance from the lines, how they are replaced to each
Yeah.
other, that there is no
Yeah.
overlaying. Maybe this is just some advices we can give in terms of a quick fix. Yeah,
Yeah.
that's
Yeah. Yeah.
good. Okay, James, maybe you can share a short video and information regarding the situations which can happen or occur in the conditioning of the gas sample of the probe. I mean, now we are in the part of cold systems, not hot wet systems, but cold dry systems. So CEM systems which need a cooler in order to remove or to dry the probe, in order to remove the water from the gas sample probe. Yeah.
Yeah. Is it able to switch over? Are you able to see?
Yeah, I can see it here, Jim. Yeah.
Yeah.
Let's run it.
The cooler outlet. Yeah. The cooler outlet.
So, James, what do we see here?
Yeah, there are several reasons why cooler, the outlet, is supposed to be dry. All right, it's supposed to be dry in the terms of a 3 degrees C after cooling. What really happened is that at the point of inlet, all right, at the point of inlet, many people has the heated line 180 degrees. All right, it heated all the way onto the analyzer cabinet. He enters the analyzer cabinet. All right, it stops there. It stops there, and then the tubing, naked tubing, is unheated, maybe as long as 1 meter long. All right, and then it goes back all the way to the cooler. That defeated the whole purpose of this holding temperature. This 1 meter length, it actually lost all the heat. It dissipated all the heat, which means that is the sample now at the point of enter, it is below acid dew point, below water dew point. All right. The purpose of the cooler, why is it so expensive, is to do a thermodynamic exchange, whereby the very hot gas comes in, and the cooler has to take this impact, all right, in the shortest time to cool the very hot sample all the way down to a 3 degree C. all right, that moment of thermodynamic squeezes out all the water, all right. But many system integrator has made these big mistakes whereby the naked or unheated tubing, as long as a 1 meter length, it goes that way. It defeated the purpose. It's one reason. One reason. Second reason is that every exchanger is limited to a flow capacity. All right. For example, for ours would be 2.5 liter for one exchanger. Just one of the model. We have so many models. Yeah.
Yeah.
What happens if you select only one exchanger because of competition, because you want to cut costs, and then you buy a gas cooler with only one exchanger which can handle 2.5 liter per minute, and your sample pump is sucking 5 liter per minute. What happened is overloading. The speed of this flow rate going through is much faster than the gas cooler can able to cope. Right? This is the second phenomenon. So there are other phenomena on this area. Another one possibly is that the sample itself coming in has saturated with water. So much water, all right, coming in. So, and the condensate pump is not able to remove the water, right? And the flow rate, you are not able to pair up with the sample flow. That is another possibility. So in a nutshell, a good gas cooler with all this combination, we must have so the question is, what do you mean by a good gas cooler? What do you mean by that? Yeah. Why do you pay so much?
Is the right gas cooler? You're right. But Jensen, I mean, quick fix. Let's pretend you choose, let's say, Peltier cooler, and the ambition temperature is too high. In these type of cases, I think what can you do? You can try to you can try to use an air condition to bring down the temperature in the room itself. But also, if you have the situation that there is too much water in the probe, you can think about pre-separator, for example.
Precisely, yeah.
And a pre-separator would be something we can recommend, and you could even install in a later stage. It's also, we offer the option that you can integrate the pre-separator inside the gas cooler. But like Jemsen says, if you choose for the wrong heat exchanger, the wrong layout, that could be also something crucial. If this happened, what can you do? Maybe an additional cooler, which could cause additional problems. Because then you have the second stage cooling in a different. So in this case, we would also recommend in your calculation. This is not a really quick fix idea, because then you already choose the wrong. You already made the wrong selection, but it's important to give you a little bit buffer. Capacity buffer if something changed, that you will be on the safe side. And maybe also something, because you said that, Jemsen, that is a task for the cooler to remove the water until a certain, you said 3 degree outlet dew point. Some other operate on 4 or 5 degrees C outlet dew point. I think the importance is that the outlet dew point is constant, and therefore you already mentioned it is also important to ensure that the flow inside your system is constant. Because always consider, if you do any changes to the flow and the pressure situation in this complex system, this will cause a change of the outlet dew point, which means a change of the remaining water in the probe, and this will also cause the accuracy and the reliability of the analyzer or of the analyzing you are doing from the probe, right? Yeah. So Jemsen, I think we offered to answer here some question. There is one question we can see here. Hello, what is your best approach? First of all, hello, Muslim. Wow, Jensen, that's a nice that's a nice application, huh?
Okay, yeah. We did many sampling systems on the analyzer side, right? We do not offer rotating kiln a complete solution. We do not have a scavenger probe. We do not have a cooling, oil cooling or water cooling system, and we do not have the PLC control. And the last thing is that what we have is only the analyzer sampling system of the rotating kiln. So what we have been doing all this while is we are the third party who provides and supports solution to a rotating kiln supplier. All right. So the answer is that we do not provide complete solution, but only at the analyzer side.
Yeah, yeah. Yeah, that's true, and even then you can discuss strategies like the double back purging,
Yeah.
even maybe pre-filter. So, but
However,
this is yeah. Sorry, go
however,
on.
please come to us if you want solution. All right, for your preheater, your cold silo, your calciner, all right, or your cold bunker. Please come to us. Except the scavenger probe at the rotating kiln.
Right. Right. Yeah. This is a different technology. That's
Yeah.
true. Okay, dear Jemsen, wow, already 1 hour gone. I appreciate it very much again, the great time here with you. As you can see, I think we will never stop talking about that. But that's real passion, eh? No, I think it's great. I hope we could give yeah, some good advices. I mean, the best advice is always talk to the right people in designing your application and designing your sample handling system. But also a nice offer, I would say, really exclusive offer. Tobias, maybe you can also share the link to Jemsen's Calendly session. So I think that's a nice yeah, way of getting into contact with us, and we help you out even if you choose the wrong components or manufacturer. And I think we can help
Yeah.
you finding the perfect sample gas
Yeah.
solution. Even if it was not before.
Yeah. If you do
So
need, if you do need systems that you need to retrofit, that means you have a problem, you want to retrofit. I probably am able to be quite helpful in this area.
I'm sure you are. I'm very sure you are. All right. So thank you so much, Jamson, for your time. And thank you, everyone out there. And we see you next month. Stay safe, guys. And bye-bye.